Hi students, from today onwards we are discussing about a concept called as reflection of light. Reflection of light, which is going to be helpful for the students of class 10th. Okay, so let me start with the topic called reflection. So first we are going to recall the concepts that we have discussed in previous classes. So let us consider this is a plane surface, and what is called as reflection? When the light is falling on a surface, so this is the light ray which is falling on a surface, and again it is going to bounce back into the same medium, then this phenomena is what we called as reflection. So this is what we called as incident ray, this is called as a reflected ray, and this, which is very important here, is called as normal. Okay, this is called as normal. So what is called as normal? Any line drawn perpendicular to the surface is called as normal. For a surface we can draw infinite normals, to a surface. Now what this angle is called as? Angle of incidence. This angle is called as angle of reflection, and we all know that angle I is equals to angle R. That is what we called as plane reflection. Okay, so what is called as angle of incidence? The angle made by the incident ray with respect to the normal is called as angle of incidence. What is called as angle of reflection? The angle made by the reflected ray with respect to the normal is called as reflected ray, and we have to understand angle I should be equal to angle R in plane reflection. Okay, so this is what we call as reflection. So when the light is going to fall on a surface and it is bouncing back into the same medium, then this phenomena is called as reflection. And we all know about plane mirrors, and we have studied about plane mirrors in the previous classes. See, this is a plane mirror, and let us assume there is an object which has been kept here at a distance u. So u is the object distance. This is the object. Okay, let us take this is the object. The object has been kept a distance u from the mirror. Now where the image is going to be formed? Image is going to be formed here. Let us take this distance is v, which is called as image distance. U is called as object distance from the mirror. V is called as image distance from the mirror, and we have to understand U is equal to V in the case of plane mirror. In the case of plane mirrors, we can say U is equal to V, and another important property is size of the object is equal to size of the image in the case of plane mirror. So object size and image size both are same in the case of plane mirror. And another important thing is, in plane mirror we are always going to get a erected image, and the image is erected, and it is called as virtual image. So image is erected and it is virtual in the case of plane mirror. So we have studied about some of the important phenomena or some of the important characteristics of the image formed by a plane mirror. What is the first property that we have studied? Object distance is equal to image distance. Second one, size of the object is equal to size of the image. Third one, always we are going to have a erected and virtual image, because image is going to be formed behind the mirror. If the image is formed behind the mirror, then the image is what we called as virtual image, which cannot be caught on the screen. We'll discuss that again later. So now we are going to see another thing, that is called how this phenomena is going to be occur in spherical mirrors. Okay, let us assume that it is a sphere, and we have taken a small portion from the sphere. So this is the small portion from the sphere. Now I'm just silvering the outer surface. So the outer surface has been silvered. then the inner surface behaves like a reflecting surface. This type of mirror is what we called as concave mirror. So this is called as concave mirror. It is one type of spherical mirror. Now we are going to see another thing. Now this is the sphere, and we have taken a small portion from the sphere. Now the inner surface is silvered. Now the inner surface is silvered. Then this type of mirror is what we called as convex mirror. What type of mirror it is called as? It is called as, this is the reflecting surface. This is the reflecting surface, and this mirror is what we called as convex mirror. So these are the two types of spherical mirrors we have. One is called as concave mirror, other is called as convex mirror. You see, try to observe here. Now if I am going to keep my hand like this, see. Now if the outer surface is silvered and this is called as the reflecting surface, then this mirror is what we called as concave mirror. Now observe the hand carefully. If inner surface is silvered and this surface is reflecting surface, then this mirror is called as convex mirror. So how many types of spherical mirrors are there? Two. What are they? Convex mirror, concave mirror are the two types of spherical mirrors. We have this mirror. If it is reflecting surface, it is called as a concave mirror. Okay. If it is reflecting surface, this is called as convex mirror. These are the two spherical mirrors we have. Now we are going to understand important terminology of the spherical mirrors. Now, can you guess what type of mirror it is? Okay. The outer surface is silvered and this is the reflecting surface. This is the reflecting surface. Now, what type of mirror it is? It is called as a concave mirror. This is called as a concave mirror. Okay. Now, see, this is the concave mirror. This is the concave mirror, and this is having a geometrical center here. Am I right or wrong? Is this part is called a geometric center? So this is called as geometric center. This geometric center is what we called as P, stands for pole. So P is called as geometric center of the mirror. So what geometric center of the mirror is called as pole? Okay. Now we are going to understand, if it is a sphere, I'm completing it because we know that this is definitely a part of the sphere. Now definitely it will have a center. This center is called as center of curvature. This is called as center of curvature. So this is the center of the sphere from which this part has been taken. Now if you are going to join P and C, this is an imaginary line which is going to join P and C. This line is called as principal axis. This line is called as principal axis. So what is principal axis? The imaginary line which is going to join P and C is called as principal axis. Now P and C, the distance between P and C is called as radius of curvature. This is called as radius of curvature. So PC is called as radius of curvature, denoted by the symbol R. Now the midpoint of PC, the midpoint of PC is what we called as F, which stands for focus or principal focus. So F stands for focus or principal focus, which is the midpoint of PC. Now see, this distance and this distance are equal. That means the distance between P and F is equal to the distance between F and C. Now distance between P and F is what we called as focal length of the mirror. So distance between P and F is denoted by the symbol small f, which is called as focal length of the mirror. So what is called as focal length of the mirror? The distance between pole to focus is called as focal length of the mirror, which is the half of radius of curvature. That's why we can write F is equal to R over 2, or we can write R is equal to 2F. That means if it is given that there is a spherical mirror whose radius is equal to 15 centimeters, then what is the value of F? F is exactly the half of radius of curvature, which is equal to 7.5 centimeters. If it is given F is equivalent to some 14 centimeters, then what is the value of radius of curvature? We know radius of curvature is twice the focal length, which is equal to 2 times 14, which is equal to 28 centimeters. So the important terminology that we are going to see here are, we should understand what is called as principal axis. We should know what is called as center of curvature, principal focus, pole. We should know what is called radius of curvature and what is called as focal length. So these are the technical terms every time that we are going to encounter while we are going to complete this chapter. Principal axis is an imaginary line. C is the center of curvature. F is the focus. P is the pole. R is radius of curvature. F is focal length. So now we are going to see the same for the convex mirror. Okay, now see, this is a convex mirror, then we have to silver the inner surface. This surface has been silvered. Now, can you please tell me where P is located? Can you recall where P is located? P is going to be located here. This is P and this is what we called as C, and the imaginary line which is going to join P and C is what we called as principal axis. Now, this is called as F. This distance is what we called as R, and this distance is what we called as F. So now we understand what are the spherical mirrors we have. We have two spherical mirrors. They are convex mirror and concave mirror. Now, how reflection is going to be occur here and whether it is going to obey angle I is equal to angle R or not, that we are going to see. See, for the plane surface, we have no objection. We have no doubts at all because this is the silvered surface. This is called as normal. Now you are going to understand what is incident ray and what is reflected ray. So this is plane surface. But now our surface is like this. Okay, now this point is what we called as P. This is called as F and this is called as C. So now we are going to understand how you are going to say angle I is equal to angle R here. See, let us take, this is incident ray. This is the incident ray. Okay, this is our incident ray. Now, in this case, we have normal because normal is perpendicular line. But in this case, where is we are going to draw the normal? The normal is the tangent drawn to the surface. See, this is the tangent. You know tangent? Tangent is a line which touches the curve at only one point. So now try to understand, this is our normal. This is our normal. Now we can easily understand where the reflected ray will be. Reflected ray will be something like this. So this is called as angle I. This is called as angle R. And we know that angle I is equal to angle R. So angle I is equal to angle R is the rule for plane mirror, convex mirror and concave mirror. All the three types of mirrors we are going to have this rule. So in the next class, we are going to see some more details regarding to the spherical mirrors. Hope you understand the lecture. Thank you.